law of sine and cosine last week. Now we will learn how to apply those laws with the real life situation problem. So usually you will see some situation described on the context, and probably accurate diagram based on the directions will be a big help, right? So then it's technically utilize the skills and the method that we've been learning from 5.1 will be applicable to find the missing angle measures or missing sides, right? And if you guys already tried the practice problem for section 5.2, it only includes 5 problems. And then technically, so each one was just like a part by part of the problem. So it's technically dealing with the 2 situations with just separate parts, asking missing the measurement. So as long as you know how to utilize law of sine and cosine and when to use those methods, and you're good to go. And also additionally, there's 2 examples that I'm about to give you guys, okay? All right, so let's take a look at example. Okay, example number 1. Find the side BD. Where's the side BD? We can see there's multiple triangles depicted with the situation there. And now BD is here. So point B, D, and from here to there. Now we are finding the length of segment between point B and D. Then we are given with some information scattered all over this diagram here and there. And then the angle alpha is measured 31.4 and the angle beta is measured 42.5. And then here it says height. Then if that's height, then it tells us further with the angle created the side is 90. Otherwise, it will not be the height there, right? Okay, then notice since we are focusing on finding this segment here, and we will name the segment with a certain letter so that we have convenience to call it. Let's say it's Y, right? And besides that, we are given with the side length between A and B, it's 1570. And we can also find the angle right next to the angle beta as well, because it's 180. And then we can simply find the measure the next to the angle beta by subtracting 42.5 from 180. Right? Okay, so then I'll show you the approach of this problem step by step. Okay, now, as I said, we can go ahead and find the angle measure right next to the angle beta, because this is 42.5. Then if we subtract that angle measure from 180, then it gives us the measure 137.5 as the angle next to it. So let's notate it, it's 137.5 there, okay? Then notice we can utilize the triangle there, and I will highlight the triangle for us to use next step. Here. Okay, now I know the measure of angle alpha. And I just found the angle measure next to angle beta. Then within the triangle that is highlighted in yellow, then we can find the third angle on top as well. How do we find it? You can subtract the other two angles from 180 again. So 180, and then we subtract 31.4, subtract 137.5, and then it gives us what? 11.1. So where do we notate the 11.1 there? It's on the top right there. So 11.1 degree. But what is the purpose for us to find the third angle of the yellow highlighted triangle? Because it can make the situation possible for us to utilize law of sine. As you see, the angle measure 11.1 has the opposite direction of side measure given here, 1570. 1570 here, right? Okay, then the law of sine for us to utilize here can have the ratio between side measure 1570 and sine value of 11.1. Then it opens up the opportunity for us to either get the side measure either AC or BC. But since we are aiming for the Y value here, BD, and let's find the side BC, which is highlighted in red here. So let's find BC by using law of sine, okay? So then law of sine currently will get to this point. Sine value of 11.1 over the side value of 1570 will remain the same ratio over sine value of 31.4 over the side BC, right? Then you cross multiply and isolate this equation for BC. Then BC will be rewritten as, 1570 times sine value of 31.4 divided by sine value of 11.1. Then if you calculate this correctly, you're supposed to get the approximation 4248.7 something, but probably it's gonna be specifically asking you guys what digits after the decimal that you're supposed to round, and then let's say it's 100th, and then you can just have rounded value with that. Okay, now we found the side measure of the segment BC, but it's not quite the final destination for us or this problem, right? But you can utilize it. So then the red highlighted side is about 4248, right? Then with that, we can use another set of law of sine here, because we are given with the angle beta there, right? So then now let's aim for using this green highlighted triangle with the fact this is height, and then I know for sure I can confirm this angle is a right triangle. So then it's easy. Now another set of law of sine for us to set is BC was 4248.79 over sine value of, now it's 90 here, so 90 is the same ratio with let's call the BD as a Y, right? So then Y over, what's the angle measure here? We haven't gotten the value there, but it's easy. How do we find it? Because 180 minus 90, this is 90, and we are given with 42.5 as the other angle measure. And then that gives us 47.5, right? Then that's gonna make the denominator with the sine value is 47.5 there. Then we rewrite this equation here so that we can isolate y with 48.78. Oh, it's been like 49. Sorry. 49 times sine value of 47.5 all over. We get to divide all over this sine value with 90. But as you already noticed, sine value of 90 is 1. You remember that on top of the unit circle, sine value of pi over 2 on top of the unit circle was 1, right? So then it's just simply give you approximation with 31, 32, hmm. 3132.54, and that was supposed to be the value for the measurement of the segment Y. Okay, so we get to use multiple times of law of sine, and it got us the missing measures that we were aiming for finding. Okay, any question? Good? Okay. Save it. And we will move on to the second example here. Okay, so on the notes that loaded on the module, and if you click it, and then it's gonna still show you the slides that includes all the steps there. Then example number 2. And this one doesn't come with the given diagram, but read the context carefully so that you can come up with your own diagram, right? And it should be very accurate, right? So a post is supported by 2 wires, one on each side going in opposite directions. So imagine there's a post in the middle, and then from the top of the post, and then there's 2 wires going opposite like this. So the situation looks like this. The post is in the middle, and 2 wires from the top of the post going opposite direction so that it supports that post just standing. Then creating an angle of 80 degrees with this 2 wires on top. And the ends of the wires are 12 meters apart. So then this end and then that end, and then they are 12 meters apart, right? And one of the wires creating 40 degrees of angle with the ground, okay? So if you try to make your own diagram, and you can check your work based on this context if you got the situation right. Okay, this must be the diagram for the situation. So now this is the post. And then these two sides are the wires. Then, as it was indicated, this is 80 degree. And it doesn't matter which way you pick, but one of the wire makes 40 degree with the ground. And then each end of the wires on the ground are apart 12 meters, right? Then, as you see, the red highlighted oblique triangle can be figured all three measures because it's within the triangle. We already know two measures, 80 and 40, and that makes 120. So then that leave us the third angle was a 60. So which one is a 60? This is 60, right? Then you can utilize the pair with the 80 degree and the side measure 12 on the ground. Then that's gonna be the starting point of law of sine. Then you can go step by step, that you can find all the measures, both of the wires, right? So then if you click it on the notes, and then it will show you step by step and the measures that you are supposed to get. And then here we are calling each wires with the lowercase a and lowercase b according to the way that it named around the angle, right? So it should be helpful for you guys to do it.